Hello students, welcome back. Let us solve another question from your question bank of Bangalore North University for 4th semester students. The question is as follows. If the diameter of the central zone is 2.8 millimeters and a point source of light of wavelength 660 nanometers is placed 6 meters away from the zone plate, find the position of the primary image. Okay, so let's write the given data first. Even before jumping onto the data, hope you remember what your professor told about the zone plate. What is a zone plate? A zone plate is just like a convex lens. Okay, what is the difference between convex lens and zone plate is? Convex lens works based on the principle of refraction, whereas zone plate works based on interference of light waves. How does a convex lens look like? It just looks like this. If a plane wavefront is incident on the lens, it just converges all the light rays, right? Even for that matter, we don't even have to think of it as plane wavefront. You can say if light rays are incident parallelly onto the convex lens, on the other side of it, it gets converged to a point which is called as principal focus, right? This distance between the lens and the principal focus is called as focal length, right? What happens in case of zone plate is that zone plate is just made up of a normal glass plate on which alternate dark and bright concentric circles are marked, just like this. The zone plate looks just like this. Wherever I have drawn blue lines, those could be opaque regions, okay? And the light passes through the transparent regions and then it undergoes interference, causing all the light rays to fall on one point, which is again called as principal focus, okay? And the radius of each zone can be found out. How is that? Let's say the focus is here, the focal length of the zone plate is here, let's say it is there, and if this is the first ring, the rings are made in such a way that the distance between the focal point and each one of these lines is lambda divided by 2, meaning let's say if the distance is let's say lambda over here, the distance between this second ring and the third ring is lambda divided by 2. Third ring and fourth ring is lambda divided by 2, like that. Okay, so let's say if this distance is f, then this distance is f, then this distance would be f plus lambda by 2, then this distance will be f plus 2 lambda by 2, and then this distance is f plus 3 lambda by 2, and so on. Okay, if the central region is opaque or dark, it is called as negative zone plate. If it is transparent, then it is called as positive zone plate. Okay, all the theory apart, now with this knowledge, let's start writing the given over here. Let me get rid of this first. The basic thing you have to remember is that a zone plate is nothing but a convex lens, but the physics behind is different. Whereas the physics behind convex lens is refraction, whereas for zone plate it is interference. So the given is the diameter of the central zone is, that is D is 2.8 millimeters. Here for some reason, because in the formula radius is used and not diameter, let's convert this diameter into radius, that is diameter divided by 2 becomes radius. Diameter is 2.8 millimeters, radius will be 1.4 millimeters, or it is 1.4 into 10 to the power of minus 3 meters. Alright, and a point source of light of wavelength lambda is given over here, which is 660 nanometers, that is 660 into 10 to the minus 9 meters, then is placed 6 meters away from the zone plate. It's just like saying there is a convex lens and there is an object which is placed at a distance of 6 meters. Let's say there is an object, a candle or something like that. Okay, so here what is the object here? Point source. Point source is the object, right? So don't you think that 6 meters becomes your object distance, which is u? You used to use it in the formula for convex lens, right? U is 6 meters. Find the position of the primary image. You are supposed to find out what is V. So V is equal to question mark. Now you know what to do, right? You have to just use the formula 1 by f equals 1 by u plus 1 by v. This is our popular relationship between focal length, object distance and image, right? So what is f over here? That is what we have to find out. According to the formula, f equals r square divided by n into lambda. We are not going into the details of derivation of this. As I just told you, zone plates are nothing but concentric rings, right? I'll just brief out as to how you find it out. So let's say this is f. These are the zone plates. So this distance will be n times lambda divided by 2. Isn't it? This is the focal length. Let's say we are finding the radius of the nth ring. Then I can write this as Rn, right? Using simple Pythagoras theorem, what we can write is, f square plus Rn square is equal to the hypotenuse. What do you think is the hypotenuse? It is just like f plus the length of this one would be focal length plus number of the ring multiplied by lambda by 2, right? So that is the distance. To plug in into the Pythagoras theorem, we just have to do f plus n lambda divided by 2 whole square, right? Now if you simplify this and if you approximate, since lambda is really small, squaring it makes it even smaller, so we can ignore it. N square and lambda square can be ignored. That way, by simplifying all these things and calculating this, we get this formula. Now let's find out the value. F equals r is 1.4 into 10 to the minus 3 whole square divided by n. What is n? As I told you, it is the order of the thing, right? So, since it is given, it is a central zone. The radius is for the central zone. For central zone, n is equal to 1 into wavelength is 660 nanometers, 10 to the power of minus 9. So, f becomes 2.97 meters. Now, let's plug those values here. F is 2.97 equals u is 6 plus 1 by v. Rearranging the values, we get 1 by v equals 1 by 2.97 minus 1 by 6, or 1 by v equals, simplifying this will give us 6 minus 2.97 divided by 6 into 2.97, which is 0.1700. Let's not take the units now. Reciprocal of 1 by v is v. 1 by 0.17 gives you 5.88 meters. So the image distance is almost equal to 6 meters. That is your answer. Now just to revise, it's just like asking the object is placed at a distance of 6 meters and the focal length is this much. What is the image distance? That's all. You have found it out here. So any questions related to zone plate, or if you want me to derive the expressions and derivations related to this, just comment. I'll be really happy to do that for you. All the best, students.